Okay, I'm back. Sorry about that. Did anyone of you have any questions so far? Okay, so we're going to cover the file management, file I/O, and I was discussing the memory. So you could see in here, you get it from the Linux as well as on Windows. You could see that this 12 gig of physical memory is available for this machine. But in order to just create files and directories, you run certain commands with the operating system and certain commands within the Python scripts. So one of the modules that we were using inside of Python was the OS module. Another one is sys module. And here, let's say I'm on Windows. If I want to create a directory, do a directory list of commands, and I want to send this one to a file, let's say called file dir1.txt. Now, this dir1.txt did not exist, but by using this redirection symbol greater sign, I just created that file. So if I do a more dir1.txt, the output that was normally was seeing on the screen, by doing this, I send it to that file. And that's a flat file. So if I just do the same thing here on the Unix side, and I say ls-l normally give me the listing. If I say ls-l star.py, it will show all the Python scripts. So if I want to say ls-l star.py, greater sign, say files let's say files less.text, then I could just say now files less.text. I just create that file. Normally, if this is a flat file, on Unix, you could see this dash is showing here. Let me just minimize this window because that, so right here, you could see that is a dash. So that's a dash, clear the screen and then make this command one command. You can see it's a dash here. And then there's 3 characters, read, write, dash, means this file is readable, writable, and then not executable because it's a flat text file. And then by the owner is in this case is wlutfi. If I type in ID, my user ID or ID is wlutfi and group ID is wlutfi also. And then I also belong to these other groups here. But this file is owned by me, and then the group is also myself, and this is the size of it. This is the date that it was created. There's only one link on to it, and then there's 1920 is the timestamp of that file. But this is the link right here. So the file, this October 1st is the date that today it was created. You can also get information on this one, files_less.text. And this is a statistic information. So you could run a stat and notice that access, modification, everything is written. Basically, all the information that are listed here about the file, this is written in a data structure called inode in Unix, and that inode is similar to a FAT or a FAT32, or depending on the FAT32 has a structure, but the file system in this case, FAT32 or NTFS is equivalent to extended 4 file system. So this is, if I do a file this to say what type of file it is going to say it's a text file, ASCII text. And if I say type the command name, if it is a binary, it will show that, like you say type -a, let's say file itself, the command that I use here, that is the on user bin, and then you see that is a file. So file user bin file. Everything on Unix is either a file or a directory, but the directory is also a file. device is a file, a terminal is a file. Everything on Unix is a file. So the way when you create files, by manipulating these files, depending on whether they're executable, text file, object files, shared objects, dynamic link libraries, or .so files on Unix, equivalent to .dll on Windows, they're just basically files. And then based on the header of that file, the operating system knows what type of file you're handling. So here, if I just go in Python, now I can import the OS module, and then I can read and write that file from within the Python session that I open. So here I could say os.system, and then now I can do a cat for files underscore list.txt, and I could read the contents of that file. Or I could do a list, and instead of cat, I could do a list -l and then see that file there. Or I could do a stat like I was doing it. So these are Python object. So if I do a type on OS, it says this OS is a module. But type of os.system, system is a method. So sorry, system I typed without the S. System is a built-in function or method of type operating system. So if I do a dir of OS, then a lot of the methods that are available within OS, and one of them is system. Another one is like, for example, if I want to make a directory on this system, let's say os.system, and I run the pwd current working directory that is there. Let's do the ls by itself, ls, without any -l. So now this is my list of directories that are files that are there. If I want to just say find .-type d, this will just list on this directory all the files that are directories. And then if I just change that one to a regular file, ordinary file, that shows all those ones. But if I want to just say, show me all the .py files, that was not interpreted because somehow a known argument to the type. So yeah, that is, I have to change this one to a name. So, and then code this one because I'm looking for that inside there, then now it works. So this find command, it says find from the current directory where name is matching star.py. And then now if I'm looking at this kind of things, I could do the same thing on Windows. I just have to use different command. And if I just do os.system, I could say, and let's create another file using the OS level commands. So I could say copy, let's say, what is the name of that file? File underscore list.txt to f2.txt. Let's say if I just make a copy of it, since the file.txt was not showing, it says that I did not have it. I must have had a different name. So I go do ls star.txt, and it will show files.txt. So I change here files, and then it finds it. Now it created that file using the copy command, f2.txt. Now look at the content of 2.txt. So if I want to just do a difference between these two commands, they're the same files. There's no difference. But if I do ls-ld, notice that they're exact same size, same thing. So right now I'm showing you when inside Python how you can use the os.system method of OS module that you could run the operating system command. You could do exactly the same thing on Windows, except the commands that you pass on as argument has to be UNIX, a Windows operating system. For example, let's say here, you come in here, say Python, and then say import OS, and then os.system. Now, if you want to just get a directory listing like ls-l, this is the directory. So if you want to send this to a file called files.txt, then now you created that one. So dir of that one will just show that file. And if you want to see the cat or equivalent of it is type. So that would do it. And then if you want to do a copy, and instead of CP, you do the word copy, files.txt to new.txt, let's say, or f2.txt like we did there. So I could remember what files. And then you could do compare CMP. Let's say compare on Windows, it might be compare. Yeah, files or compare, okay. So that's name of the first file is files.txt, and then f2.txt, option, no option, files compare, okay, no. So you could do a lot of the OS level commands, and here if you just forgot about certain commands, you could just do a help on it. And then a list of the commands are showing here. The list of Windows operating system are very limited, about maybe 200 commands. But here on the Unix is not. So if I just do on the, let's say, ls-l user share man pages, this man pages, which is stand for manual pages, is a lot of the commands. So for each of the commands that you could see, like man1, man2, 3, 8, all of these ones are directory. And then in addition, there's other ones that are related to specific utility and resources that are used. So just for looking at user man1, sorry, man and then slash man1, you could see that there's so many of them. If you just do a word count on it, just under man1, there's 1,700. And then if I just change this one to a star, looking for all the man pages, do a word count on them, and there's 6,300 just on those ones. There's altogether maybe 13,000 or something. I just generated the man pages for these ones, and then through a web page. You could do that then using a Python script, write a Python one page, and then it will just generate that one for Unix, Windows, everything. So the files that we are doing here, we're creating files and we're tagging it, we're updating it, everything. You could also do os dot, let's say, make dir, and then put a new directory called my new dir. So if I just create that one using the Python make dir, now this one is, and instead of this, if I just say ls-l my new dir, notice that this one is empty, but if I do ls-ld, it shows that this is a directory, and the first one, instead of being a file, a dash, it's a D. So then if I just want to say, if this is a directory, then do something with it, I could do a lot of things with it. And then at the same time with make dir, or maybe rename. Let's say if I just use the rename method, rename. So rename requires maybe two files, and then I want to rename something. So my new dir to say change it to new dir. Now this one basically did the rename method, and then if I just do my new dir, it's no longer there, but new dir is there, as you can see. So the rename worked. So there's like dir of OS, you can see there's all these methods that are there. And then os.write, for example, is going to write something to create it. So if I just say os.write, and then now I have to have a file descriptor to write something to the file descriptor. This is a test. It's going to just say, well, what do you want to write to? I did not open a file descriptor. So in order to do that one, in Python, you have to do something called a file descriptor. You read the file. Let's say the file that we were doing here ls, sorry, this one, ls minus l star.txt. So we had a file called f2.txt. So let's open f2.txt. If I want to just read the content of that file in text format, I could just say a file descriptor is equal, there's two ways you can run. One way is that you open a file descriptor. A file descriptor is basically a file handle. It's a way that you just point to that file by a handle, and then you read and write from that file descriptor. And then once you're done with it, you close it. But if you want Python context manager to take care of it, then you use the with statement. And then when you use the with statement, as soon as you're done with it, and the context manager is going to close it for you. You don't have to open and close it. But I will show you the difference between the two right now. So right here, notice that if I just want to open a file, I just use the open function. In this case, I'm going to open which file? I'm going to say f2.txt. And then in what mode I want to read it. This is going to say read it in read mode, so I can read it. So now if I just do file descriptor.mode, you see that it is open in read mode. And then if I just want to read one element of it, and then I could just say fd.read. Let's say I want to read the entire text in one shot, read lines. Then this one is going to read it all, the whole thing in one shot, and is going to do it. Now if I say file descriptor dot seek, which is tell me the tell me where the file pointer is, that is actually at the last element of this file. So if I just say os.system and then say word count minus L f2.txt to see how many words are there. There's 26 lines. And then if I just do a character count, there's 1438. And notice here, the file tell, end of it is 1438. So I reached the end of file descriptor by reading it. If I want to just do file descriptor.seek, and I want to go back to the first element, now I set that one, and then I just do the fseek.tell. Now it's going to say that it's there. So this time I read seek only one line at a time, read it, the whole thing in one read statement is going to just do the same thing, and then fd.seek not .tell is going to say that I reached the end of it. So now if I just do another fd.read, it's going to say, well, you reached the end of it, there's no more element to read it. The more I try to do it, it's going to just say you're pointing to that one. As soon as I change my file's descriptor to seek to read the first element, now I can do another read, it's going to do it. So this one will just do it. I also could do this seek and then say for a line and fd print line. So using a for statement, I could just print that entire thing the way without those new line characters, because these ones, when you're reading within the file descriptor, notice the new line characters are not interpreted. But when you do the function print statement inside this for statement, you do this print statement line. Now line is passed on with those information here. Every time it sees a new line, and the function print statement is gonna just convert it to a new line character, so it prints it nicely there. And if you just do something like this, and notice that if you do this, it is going to print it, because now file descriptor is already closed. Already end of files. So file descriptor.tell. Next time if I do file descriptor.tell, you have to use it as a function. It's already end of it. So next time I'm just doing this print statement, this is not going to print anything because I'm already reached to it. So sometimes if you want to open a file for writing, let's say I'm going to say file descriptor is equal open, and then I say file descriptor, I'm going to say file 3.txt, and then I'm going to open it for writing. This one is saying basically create a new file, and then if it doesn't exist, create it as blank. If you put the W, meaning that it's going to open it for write, if there's context already on it, it will override it when you W. If you want to just not override it, you just do A for append. But in this case, since it's a blank new file, I could just open it like this, and then do my file descriptor.tell to 0 to point to the first element of, sorry, I have to do another file descriptor because the other one, file descriptor, the first one that I did, I'm going to just say open, file 2.txt as read. So you have to keep track of them as this. So I could have a file pointer called file descriptor 1 read, and then for reading, and then file descriptor 2, file descriptor write is equal open, and then the file 3.txt, and then the mode is W. So these two files are open. Now if I say type of FDR to see what is basically IO text, IO wrapper. And then the same thing with the writable, but it doesn't know which one is for read and write. The way it knows is FDR.mode. So this mode is going to tell it this is readable and that's writable. And if FDR.tell right now is pointing to the 0 element. And FDR.write, because it has not writing anything to it, it's also pointing to this. So now if I want to read each line of this and then I want to copy it to this line file, I could do for line and FDR, then say print FDW dot write, and then we just say line. So this is a file descriptor write, the line statement, but whatever we are reading here, we are going to write to that. And then once it's done, so now 56 lines are written to it, I'm going to close the file. So if I just do fdr.close, and then fdw.close, I'm going to close that one also. Notice that once you close it, you cannot read from it or write from it. So if I just say fdr.mode, it is there, but for the stat of it, so let me see, dir of FDR. So one of those ones will just show the status of it, closed, okay. And you can also check if it's closed and if it's open, their file number, seek, tell, buffer. So error, file number, closed, and then close buffer, detach, error. So if I just want to write in this case, watch what happened here with the write statement. If I just say write, the file is already closed, it will not allow me. So it just says unexpected indentation. So let me just fix the indentation, moving it here. If you want to write to a file that is already closed, IO operation close file. So it will not just be able to close it. there. And then file descriptor readable mode is there, name, file descriptor write.name. Yeah, the name of it, that will just give you the actual file name. Let me see, file descriptor dot closed. This one actually will just say if the file is closed or not. You will see the status of it. So that way you know that if this is the case, you say if the file dot closed, and then say print, please do not try to write to a closed file. So you could do a if statement else and then say print and the file is open for writing. So if you do that one, then it's going to just, in this case, it's going to say, please do not write it because that file is not open. And then at the same time with that one. So now watch the file that we open and close it. If we do os.system and then ls-l star.txt, let's see the content of the two file right here. F2 there, and then notice the size of this file is exactly the same thing. So if I want to just say do a word count minus L F star F question mark meaning that I don't care if it is one character is 2 or any other character, just this, list them. You could do that one, or you could say between character 2 and 3. You could do that one also. You could just check it. So those combination of those one, well, Unix is very efficient on regular expression. You can do a regular expression to match something. In this case, we just created 26 lines of exactly the same thing. So if I do a word count on them, you can see that both of them are exactly same lines. If I want to see, for example, type those two files, and then you can see that they're the same. If I do only a difference, there are no difference between them. If I want to just say cat minus n f2.txt, it will just show line number. Minus n means line number. And then notice that this is by line 26 lines, and then altogether is 1436 characters. So the same thing goes with file tree. So inside Python, we were able to create two files, text files, and copied it as another one. So let's just do another example. We look on the internet for a graphic image. Of something like a lion or something. So let's say lion. Actually, rather than lion, let's look at a soccer ball. Something more interesting. Let's see. Let's look at something. Soccer field. Is there nice soccer field pictures? I'm going to say water, river. So let's see if there's under images, one of these images is looking good. So let's say we do this one, and I'm going to save that one as a JPEG file or something. So just looking at that image, let's see if, let's look at this image, right? So we copy that one just temporarily to demo something. Snipping tools, We don't have to download, we just temporarily show you how you read a binary file and then how we can just do it. So I'm going to do this snipping tools. I'm not gonna copy the entire image. I'm gonna just temporarily cut and paste from this one using this snipping tools. Let's look at this one from here to here. We're gonna just save it and to a file, save it as, and let's look at it, put it on the directory we want to do it. Pictures under lectures, and then yeah, that's fine. Let's just call it image1.png. So this image1.png, we have it, and we are going to close this and then go back here on the prompt where we save the file. So let's exit out of here. Am I on the, yeah, Windows, okay. So here, start.png, there's a file called startimage1.png. And as you see, the size of the file is that, and the actual image is something like nice looking image. So this one, I want to just read this file and make a copy of it. Since I call it image1, we could use the sys images or something, you could do that one, but let's just do this. I had lectures, and then right here under lectures, let's see, simba.py, .py. So the script that I wrote for this one was already demoed with Simba. I wonder if I have it on this directory here. Oh, it's might be on the chapter 6. Chapter 6, yeah, or chapter 7 actually, because this is file.io. So simba.this, I'm gonna move that image, move this image1.png here. So now I move that file star.png. I have it here. I'm going to use copy of simba.py as image1.py. And now we open this one through Adams. So we already have Adams. So let's just go on that directory and then say file, open file. In this case, we have to go to a directory chapter 7 and look for the file called image1.py. This is the file. All we have to do is just change this file to image1, and then like I was telling you, you could use the wet statement or the file descriptor, but in this case, notice that since I used the wet statement to open a file descriptor, and then use another wet statement and nested inside to open one for reading, for writing, so I have to do that one, image1 also, and then this would be the copy of it. And then this file descriptor 2 is for writing, file descriptor 1 is for reading. But notice the mode here is read in binary and write in binary. And then in this case, we're reading one byte at a time. That's because it's binary, we have to read one byte at a time to read each byte correctly. And then as the byte is greater than 0, that means we have not reached to the end of the file. Once it is equals 0, then it's done. And then the while statement is going to be false, so it's going to terminate the loop, and then it's going to finish writing to that file, all the elements of it. But in this example, you should learn a couple of things. One is when you use the with statement, and then here again with the statement, whatever file descriptor you open, once the content of this one is done and the content of this one is done, automatically the Python file context manager is going to close that file descriptor for you. You don't have to do fd.close or fd2.close because you use the with statement. But if you did not use it and you did fd is equal and then use this open statement up to right here, then you have to close it yourself. And the way you close it is say fd.close. So this one, now we're just making a duplicate copy of this one. Since this script is running on the same location, now we can run it. Let me just save it because we made some modification. Save it. And then even if we run it here, notice that image1, there's only one file, image1.png. The other one is .py. We want to create an image1 underscore copy.png by running it. So whether I run it from command line here or run it here, it will do the same thing. Package, run, a script is going to run, and then see if it no such file or directory. So this one, it just did not find the files or directory image1.jpg. So let's see if it is PNG or something. Yeah, it's PNG rather than JPEG. So I'm going to change that one to PNG. PNG is also a binary format file, and run it again after saving it. Save it and run it. Script run. No such file, image1.png. Let's see what is the name actually. image1.png. Okay, so image1.png, image1.png. And this one says, I did not find image1.line 4. Line 4's with image1 with open as this no such file or directory image1.png. image1.png. So this one with a statement, it's not having the path, the full path to it. If I just run it from the command prompt where I am actually there and that file is there, let's see what does it find it. Is it a path problem or is it just the naming problem? .py. Yeah, so it was a path problem. Directory image. So now there's 3 files and it made a copy of it. If I just start this file, it's gonna be running it normally, showing that the same file that was duplicated. And you can see the size of that file is exactly the same size of that, and it was copied. But let's just see if we can fix the problem of that, because somehow when you look at the contents of image1.png, sorry, image1.py, if you look at the content of it, it says, open this file from the current directory that I am. And since I'm on the chapter 7, it finds it. But here, even though I'm on chapter 7, it does not find it image1.png on chapter 7. So no matter how I run it, I could close these other ones to make sure that I am not somehow pointing to that path, and just go to that file and say open file. Okay, by default, actually it is looking at the Python directory. Let's see if I could just go to lectures and chapter 7 and image1.py, and then compile this one, package, and run. If it doesn't, you could put like a dot here, dot slash, that says just do it from the current directory that I am. Let's see if it finds it from the current directory. File, save. You can also put the full path, but let me see if relative to the path to the way we are running it, and the dot slash is going to say, okay, did not find it. So I'm going to put the full path of it, which is C colon / and oh, sorry, the this was DOS. So let me try this. First, because that's relative path to it. And then on DOS, if you just use 2 slashes, meaning that the next one is a slash. Current means the current directory. And we could use the raw method to pass it on exactly like it is, so we don't have to skip it, the slash. Let me save it, save, and then let me run it. Okay, so the file is not found. Let's try the full path, C colon / and then say users / Wahid / pasadena.edu / CIS -12 012. You could also put that one into a variable and pass it on into the variable, so you don't have to type it in the whole thing. It's a really long one. Bothers me to type in that long. And we could put the image 1 to temp and just try it. Let's just put that one to temp there, and then image 1, and then here we want to write it to the temp. So I have to put image 1 to the temp directory first, and then run it. Let's say save it, and then here I say copy image 1 dot png to C colon / temp directory. So we did copy it there, and then we do a dir on it, and then look for the store.png. That file is there, image 1. So now we save it there. Let's see if it finds it and make a duplicate copy of it by just running it in binary mode. We create it in the binary status. So run a script. Yeah, this time it just says it ran, and then it successfully found it. So because we give it a full path of where the file is. So in this case, if I just up arrow again, dir star.png, it will show the copy also. And if I want to just say start C colon temp, and then you can see the size is exactly the same, but I want to open it up one more time to make sure that we can read it. It's readable with the same kind of format. So you can see it is working fine. So right here, we were talking about Python file I/O. There's other examples that I showed you last time that we could do that one as well. But with Python, basically, you're reading either a binary file or a text file, and you're manipulating it. You have a file pointer, and then you have a file pointer, file descriptor that you could read from the file descriptor. With other functions like fseek, the file descriptor.seek, on C on Java, you use also seek function or seek method. But with other Java or C programming, there's similar to open, there's fread, there's fprintf, and there's fwrite, and there's fprintf, fsprintf, and there's fscanf, and there's a scanf, and there's a lot of functions that are available for you to and just do the same thing. String manipulations that are there, like last time we were talking about the string. In the C also there's a string copy, strcpy, strmem, and so on. But with file I/O management is basically you're manipulating either text file or binary files. And then even if it's a directory, it's a file. And basically the difference between a file and a directory is the file has actually the data, the directory has in the content of the directory the name of the files. So when you delete a file, it actually removes the name of the file on the top of it, like C, if it's chapter 7, that C is deleted from that directory where it contains chapter 7, in this case lectures. But and the actual file contents is not removed until you actually override it with something. So we're going to discuss also another data structure called list today. Let me stop here on the file I/O management and ask you a question. If you have any further question, any further explanation that needs to be done, please go ahead, ask me a question, and I'll just answer that one before I start the list data structure. Do you have any question?
I have a question, Professor.
Go ahead, please.
Could you go over some of the essential vocabulary of the programming that you were just doing, especially the modes you were referring to with a certain code?
Yeah, so we did discuss when we were talking about the mode or some of the things. Let's just open file descriptor again, and just to show you what I mean. So right here, I have a text file. If I go to Python, and I just want to read one of them called new.txt, let's say. So at this time, I'm going to do a file descriptor. This name, it could be anything. I could say file descriptor, whatever I want to do it. So for short, I say fd. Fd is equal, and then you use the open method. And then open, you're going to say what file you want to open. Now I have a file called new.txt. I want to read the contents of that one. So then the mode that I want to open it, if this file descriptor, I want to read from it, then I have to do R for read. If I want to write to it, then I have to do W. If I want to do append, it's writing there. W plus or A plus is also append and writing also. And then RB is read binary. WB is write in binary. So in this case, let's say I open it in read mode, I just do that. So at this time, this open function, it takes 2 arguments. One argument is the file name, the next one in what mode I want to open it. The mode in this case is read only. So I just read that one. Now if I say type of FD, this is saying that this is a file IO wrapper, text IO wrapper, input output. Basically it's that type, but if I do fd.mode, then it's going to say it's open for reading purpose. And then if I just say, tell me where my file pointer is, there fd.tell. So that will just tell me that I haven't read one element. If I say fd.read, and then I want to read 1 byte at a time, the first element is blank. Now, if I do another fread, every time I read is 1 byte at a time. That's what fread does. So in this case, if I just do ftell, notice that I moved 2 bytes. The first one I read, this one was 1, the second one. Now another one I read it with 1 byte, and now my file pointer is pointing to the third bytes. So as I go, I could read maybe 10 elements at one time, and it reads more data. So if I just say, tell me the file pointer where this is 3 plus 10 bytes. So now it's 13. If I want to read another 7, that now my file pointer is pointing to the 20th element. So file pointer tel is there, but the file descriptor dot mode, it tells me that this file is open for read. I have not checked on it. And file descriptor dot closed will show that this is false, because dot close will show that, I'm sorry, let me just do this. File descriptor dot closed will just say it's false. This is still open for reading. So that means I could do a file descriptor dot read and then read another 10 element. So if I want to read a lot more element, let's say I want to just do a file descriptor dot seek, I want to start fresh from 0 element, and this time I'm going to read first 50 bytes. Notice that all that is there. And I want to read another 50 bytes as I keep reading till it's reach end of file. Once it's reach end of file, I'm not able to read more. So this is not the end of file. So if I want to read the majority of the file, I could say, let's say 100, and then now do another 100 is already reach end of it. So if I do file and descriptor.tel, that is end of it, sorry. File descriptor.tel, this is end of it. And if I do import OS and the os.system, what was the name of the file? So let me just find out the name of the file, file descriptor.name. So if I'm looking at os.system and then I say word count minus C, how many lines are all together in that one, it should say 533. So new.text, it is just showing word count minus C, new.text, not recognized as word count minus L, WC. Let me just see, cat new.text, word count minus C. Yeah, 255, not recognized as this, because somehow it did not understand something went wrong. So os.system is not doing the thing that I want to do it. Let's see. Yeah. So something went wrong here, is not recognized. And then import OS. Let's see, import OS as O and O.system. And then ls minus L. Let's see if it does. Okay, I have to exit out of Python. Something went wrong. So now if I just exit out of Python and then I go back here and then I say import OS and then os.system, that would work. Oh, sorry, I was inside Windows. So these commands are the UNIX command. You guys should have caught me there. I was just on a Windows and I was using a Linux command. So here, this is type os.new.text. Was it new.text was the file? Yeah, new.text. So the content of it, as I was telling you before, you have to use the right command. And this one, type is the command, not cat. But on this other prompt, which is also black prompt, and so then the two prompts are almost similar for me. I had to change it. If I was using a X Windows session, I could change my terminal to have the different coloring, so that way I could just do it. I could also right-click and use the property and change the color to whatever color I want. That way, I know that which one is there, but normally I pay attention to that. So the files, if I'm looking here, OS import OS and os.system, and then I want to see a file cat test2.py, that would work because cat is there, and word count word count minus C will give you the number of files that are there inside of it. So if I just inside here, let's say I want to just say this is the file that I want to open, you do file descriptor is equal open, and then say, let's just do a wet statement rather than file descriptor. So we don't have to close it. And then here, I'm going to say with open, and then say the name of the file is test2.py, and then the mode that I want to read is for reading, and then as a file descriptor. Now I'm doing this one, I have to do 4 elements here, and then say read it. So if I want to read the entire thing, I could say for line and file descriptor, and then print, let's say line. I could read the entire line and then print it. And then at this time, if I just press enter, since the scope of file descriptor will terminate, it will close by the context manager. I don't have to save a file descriptor. So that content of that file was read, and then I just did it. So now file descriptor.name is telling me that's the name. File descriptor.closed is going to say true, because the file descriptor closed it. File descriptor.mode is still saying that it's readable by read. But if I want to just read it again, say for file descriptor.read is going to say you can't read anything. So if I want to read 10 bytes, it says that you're doing it on a closed file. So in order for me to do it, if I didn't do it with the wet statement, I could do it this time with the file descriptor is equal open, and then I say the name of the file was test2.py, and then I want to go as read, and this time I'm going to say for line and file descriptor, I'm going to say print. So let's just do something here. I'm going to say, so file descriptor.name is already there, file descriptor.mode is read, but I want to just create a line number. So we could duplicate like cat command with -n option to show the line numbers. So you could do like here, say count is equal 0. And initially you set a counter to 0. Now I say for a line and file descriptor, so I'm going to just say do. So what I'm going to do here, I'm going to say, so count plus equal 1. We're going to increment the counter, so line number 1, line number 2, then print count, and then comma, and then line. So this way it is going to print the file as well as the line numbers. You can see it is done that way. So you could do, and then if I just do import OS, and then say os.system, and then I say cat minus n was test2.py was the name, I could have just done the same thing 9 lines. And then if you want to just make sure that there's no new line characters, you could do something like this. You could say file descriptor .seek 0. So you put back to the first element of it. Then you say count is equal 0. And then this time you say for line and file descriptor, as you're printing it, you say count plus equal 1. And then as you're printing it, say print count, comma, line, and then line end is equal this. So that would just print it in a nice format, like similar to this lines. So notice that now it's line by line number the way we had it on the other one. And if you want to write it in a file descriptor, you could do it. But notice that file descriptor dot mode is still in read, but file descriptor dot closed is going to say true, because file descriptor dot closed is the name. It's false. I'm sorry, it is not closed, but file descriptor dot tell, it is end of the file descriptor 230. And if I go here to see the OS dot system and do a word count minus C on it, you see that it's 230 characters. And that's when we reach to the file descriptor 230 here, we reach to the end of it. And then if I just now say, because Python does not close it, I have to close it. So now file descriptor dot close is going to say true. Does that answer your question?
Yes, very much so. Thank you.
You're very welcome. Who was this, Sarah?
Yes.
Okay, thank you, Sarah. So, so we have 12 people, and let's go back to Python list, and then we cover Python list. But before I cover Python list, let me go here and make sure that everything here that are listed is covered already. So we went through file IO, and then we talked about file descriptors and reading, writing files, and working with file system and different type of operating system. We give you examples on those, as well as we did some demos. So that covers up all these materials that are here. And there's also some more documentation that I have on this module that you should be looking at it. Let me move this one on the side here. So on that one, basically, it will just show you some of the other modules. Like this string is a class type of a string. So when you do a type on it, this one will say type, class type. It's a class, but it's a type of data structure that you could create a string kind of objects. And then with those objects, you can do all kind of methods here, like splitting it and then striping it, and then uppercase, lowercase, search for a string, and check for is alphabet alphanumeric or is uppercase. All those things you can look at it. We also look at some of the functions with OS, like we looked at the stat, we looked at the system, we look at make directories, and so on. And then the sys modules, there's also very important modules. I'm going to cover a little bit of sys module before I jump into list, because every time we cover a little bit of it. So on list, sys, if I just clear my screen system, what is this one is UNIX. So, excuse me. And then if you do the clear screen, then I'm gonna say import a sys module. Notice the type of sys is gonna say class type or class module. A module is basically contains a number of functions and other methods that are available within a module. But inside this one, when I do sys, dir of sys, these are the methods that are available here. So if I just do type of OS, this is also going to say a module. If I do import math, this is also a module. So type of all of these ones are modules, but these modules has all these methods, and then these dunder double underscore magic method that you could use for it. For example, on the sys.path, for example, is showing you where Python's path is. So sometimes if it's relative to that path that you're working on, it will find the packages that whenever you say import math, automatically looks at the system libraries there to find out for that particular path to find it. If it doesn't find it there, then it's going to look at the site distribution packages. So some of the paths or system modules or kind of come with a standard library, some of them are not. So if it is not coming, you have to install them. And then as an example, like if I just say import a NumPy as NP, it's going to load it because that one I have downloaded. But by default, a NumPy is not available. Or import, let's say, pandas as a PD. And then no module name pandas. So if I just don't have the module, I have to install it. So if I just do import, let's say, request. If the module is not there, then I have to install it. Import, let's say, matplotlib let's say, as a PLT. And that one was there, then it doesn't come by default. I must have installed it. The way I install it, I come in here under things and say pep search or pep list to see what is already there. If the package like Python NumPy is there, then I can use it. By default, this one doesn't come. So I have to install it. And this syntax that it tells you that you have to run this one, this is just for pep modules there, depending on whether you use pep version 2 or 3, that you get some of those ones, and then you have to upgrade it. You just more often you get this information, you just have to do that. And similar to that one on DOS or Windows, you could exit out of here and say, let's say pep list, and then here maybe I installed pandas. So you could do a search of all the packages that are there, and if it is not there, because on this one I installed the Anaconda distribution. Anaconda is a Python distribution that automatically has so many packages that are not coming with regular Python installation, such as NumPy, pandas, request, and all those other ones. They get matplotlib, and all those ones get installed. So you can see, like here, if I go Python and then say import pandas as P and D, and it will show, because this one I installed it, I'm having it there. And then dir of PD, if you look at it, is a big list of it. How do I know that it's there? Because inside my Windows, if I look at the path, in addition to having Python 3.8, which is Python version 3.8.3, I also have a program data directory here. You can see program data. And then here, and there's Anaconda, directory of Anaconda 3. So CD to Anaconda 3. Inside here, there's a lot of files. And one of them is site management, is the equivalent of to PEP is Conda. But you will be using these ones maybe on your intermediate class, maybe on your advanced class. I was just showing you some of the other things that you could do with Python while we were looking at the sys module, for example. Let me just go back to sys module to show you some of the things with sys module. So here, if I go Python, and then I want to just say import, sys is by default method module that is part of the standard libraries. So if I just want to see the sys module, sys.path is showing you the path, sys.executable, it shows you the path to use a bin Python. Sys.version, it tells you the Python versions, and then sys Python version info, will give you. So a lot of these information as we go, we will look at it. Then like a standard input and the standard output and the standard errors is based on the file descriptor. So and the file sys.standard input would be your file descriptor 0 on Unix or Windows or Mac. File descriptor 0 is basically your keyboard that you're entering. A standard output would be the display, where you write to the screen, whether it's a screen display or the printer. And then the standard error, where the error is happening. So this kind of information is available to you, and we could experiment with a lot of them with sys module when we get to it. But I'm not going to cover those because the building block of Python is not covered yet, which are strings, integers, the data types of like list, the data structure list, tuples, data dictionaries, and collections. So once we cover all of those concepts and terminologies, we will discuss the rest of them, which are these kind of modules, like pip modules, like documentation. For example, let's say you're looking at the Python documentation. One of the students last time asked me if there's other documentation that I could read. And I showed you python.org and help and a lot of the idles and everything else you could search. But in addition to that one, let's do another module of Python called PyDoc. So inside here, whether you're on Windows or Linux, as long as you're on a local machine, you can just open up in your browser Python and documentation similar to the Python doc and that you see on the pydoc.org. But if you want to just open it on the local host, in your machine on Windows, there's system32, and then drivers, etc directory, and then type host. This file basically says that whenever you want to look at the local host, you're going to get the IP address of 127.0.0. And this is for IP version 4. For IP version 6, this is : 1. So if I just do ping localhost, this is just basically pinging the IP version 6 version of it. I could also do ping 127.0.0.1. It will just still respond because this is the server. So right now, if I go here on the default port 127.0.0.1, it's not going to open anything because I don't have a running web browser or certain port. And then if I do a local host here, local host is not going to do anything either because I'm not running Apache web server. I'm not running on the port. By default, if you don't specify anything on the browser, it is assume HTTP protocol. It's not HTTPS. And then it is assuming port 80 by default. But if you specify a default port, then you could open it. So on Unix machine, there's a file called etc services. etc services. This one is basically all the ports that you have on the system, it has it. So if I look for grep 80, etc services, it will say all the ports that are HTTP port 80, and then like 21 would be like FTP, and 22 would be SSH, and so on. So a lot of these ports by default are already system defined, which is port 0 to 1 to 1024 or system defined. But you can have another port that's greater than that number, 1024, which are user defined ports. You can just open up a PyDoc module. In this case, I'm going to use the PyDoc module, and then right here, I'm going to say clear my screen, clear screen, and then say Python-M, meaning modules, PyDoc. So what I want to do in this case is run the Python, but I'm going to run the module, dash M means module, and the name of the module is PyDoc, and dash P port, in this case I want to open it to 5.5s, port that number. So at this time, I'm just opening that port. Notice that it just automatically says server ready, HTTP localhost port 555, right? And then at this time, it gave me an option of browser or quit. If I type in Q, it's going to just quit that browser. It did not open it. But I want to browse it, so I will do this one. Now watch, it's going to automatically open the local host on that port, and then it's going to load. Right now, it's loading the Python documentation for me. So I can look at each Python doc internally for myself. I don't have to go python.org website, because you may not have access to the internet. If you don't have access, no access to the internet, you can still read the Python similar to the way you are doing here. Inside there, you were doing help or something. So if I just open another CMD command here, while that one is loading, because it's huge, that it has a lot of modules and it is going to take a little bit time. And I have a limited number of memory, and also many resources are open. So if I go here, Python, I could always get help here. So if I just search for modules, underscore, and then I see, sorry, I have to type in help first, and then say underscore modules, and then, so now let's see if there's module. Okay, so I'm gonna do it, let me just exit out of this and then say dir. Okay, yeah, the modules is not showing there, but I could do help and then say underscore built in. I could do it also here, help. That's much better than going inside there, because that would give me all the built-ins there. So you could get that documentation here, as well as inside help. Like let's say I read all of that one and I want to quit. I type in Q for quit. So quit, and then if I type in help here with the method, and then I say modules, and then it's going to list all the modules. And if I'm looking for a if statement or a for statement, I could do that one. But while this one is loading, we could just look at the browser. And this is the help that we were looking at, the Python doc with the modules 555. So if you look at, the port 555, that is 55,555. So if you look at the list of the packages, everything that is there, and then NumPy, for example, here is a package here. You could do this one that gives you so much details on each one of them as you go, and there's PEP and other stuff. So there's thousands of files and documentation for you to do it if you want to just get more information here. And then NumPy is so huge, so it will take a little bit to just load it on the system. And then on the DOS prompt, and the list of modules is already showing here. And this is math modules and all that things. So let's see, quit out of this one. So just wanted to show you, actually, let me exit out of this. And this is like for NumPy and other ones. So there's a lot of it, that information, if you want to just read through them. You can open it on the visuals packages. You could just click on it, and it's going to take a little bit to load it, but eventually it will just display it. And then talking about what we need to cover here. We covered the sys module, the string module last time. We covered that one also. We went through a number of the constant that are available. And here's a list of the constant that are being used with examples. We went through that one. So we're going to discuss list modules. Let's see what else. Yeah, list module here. The list data structure is also available in Python. It's a data structure, and it is mutable, which means each element you can modify it. So in order to show you a list, here if I just clear my screen and I say Python, and then I say my list is equal, and then I create a list of 1, 2, 3, 3, 4, 5. Let's say this is a simple list, and then now I say type list itself is a type, and then my list is going to show list, class list, and then if I just want to say print my list, just I created that one is 1, 2, 3, 4, 123 in this. So each of these elements of my list, sub 0 is going to print 0, 1, and then sub 1 is going to say 23, and then sub 2 is going to print 4, and then 5 is minus 1, the last one, or 3 in this case. And then length of my list is just going to say how many elements are there. So my list, this saying start, end. If you don't put anything before the start, it assumes 0. And if you don't put anything with the end, it's assumed minus 1. This is the same as this colon and this. If I just want to say only show me the first 2 elements, it will be that. And if only show me the first element, it's that. Or show me only the 0 element, is that. So you could manipulate it, and with the negative number, you can go backward from the my list. Notice my list is 5 is the last one. So if I do minus 2, it will go 4, and minus 3 will go to 23, and so on. So the my list now is a list that has length of my list is basically that many elements. So if I want to just say my list sub 0, I could assign another number to it. I could say this string. So now my list has been modified by my list sub 0, because a list is mutable. Mutable meaning is you can update it, you can change the element for it. It's not like a string element that you could not modify it. It's not like a tuple. Tuple or tuple, you cannot modify it. It's almost like read-only. If you want to modify it, you have to change it to a list or some other data type. So in this case, a list by definition, when you create it, you can have more element to it by just saying, let's say, I want to just append to the list. Say my list dot append, and I will just say Wahid. So now the string Wahid is there. My list now has more elements. So append meaning that add at the end of it. So my list dot insert, for example, insert, and then if I want to just insert Wahid on the first element of it, then I have to give an index of where I want to add it. My list now has a Wahid twice. So list allows duplicate elements. In order to just get rid of it, you have to change it to a set data type. Set is like list, but set does not allow duplicate elements. So my set is equal, then set, now set is a data structure. I could just convert my list to to do that one. Now my set is having a one type of Wahid there, because set does not allow duplicate element. And notice that my list is a list. If I look at the content of my list, it says a class type list. And then if I do a type of my set, it's going to show that it's a set. So my list has those elements, and my set has one less element because Wahid was duplicated. And then notice that braces around the set, and then bracket around the list. So length of my list is one element more in this case, because we get rid of the duplicate on the length of my set. If you want to print each element, you say for item in my list, and then print each item. You could do a for statement, you could print it. The same thing with my set. You could do that one, and then you say print item. The item is a variable. You could put I, you could put X, you could put anything. We're doing those ones. In order to get a list of all the methods that are available for my list, you can see we are just using some of the examples. So in this case, my list is there. If I want to say my list.pop, pop is going to just take the last element out. So in this case, my list now has one element shorter because the last element is there. But if I want to just remove the first element, then I have to do my list.pop, and then say 1, and then that would just take that one and the first element, my list, my list, and then yeah, 1 would, this was 0 and this was 1. So I want to just take this, I have to say index element 0. That would say that, and then my list is automatically there. Now I can add another list to this one, so I could just say, create another list, say my list 2, and is equal, let's say I create another list 2 of some numbers, say, let's say we're going to say apple, not numbers, I'm going to say apple, pear, and then banana, and then grapes, and so on. So, so if I just create another list, my list has that and my list 2 has that. Notice that now I can do my list and my list 2. I can append those two lists, my list 2. It just make the third list. So if I just say my list 3 is a content of that. So my list 1 is there, sorry, my list is there, my list 2 is there, and my list 3 is a combination of those two. I can do that one, but I cannot do addition to something. I mean multiplication between two lists or division between two lists. If you want to do that one, you have to use NumPy. So in order to do this, for example, let's say I'm going to do my list times my list 2. It's going to not allow it because that is, data structure is not allowing it for various reasons. First, list is slower than NumPy. Secondly, that slowness is not the cause of why it's not allowing it, but list is a data structure that has different data type. So some of the data type are string, and you cannot multiply by numbers. With NumPy, you can use data type that are the same. and they're contiguous memory locations, so they're much faster to manipulate a list in comparison with a list. So in this case, let's say I want to just do my list 2, which is those bananas, and then I say my list 2 times 5. Now I added that numbers, multiply it, but I just grow that one. If I just do my list 2.2, it basically, if I do it with 200, you will notice that's growing bigger. So the list, you want to do something with it, you can increment it by doing it. So if I just create a list of one element, and then I want to say zeros is equal, and then I just say 1 0 here, but I want to write it 5 zeros. Then now zeros is a list of 5 elements of zeros. So length of zeros is just basically 5, and then each one of 0 sub anything, in this case is 0 sub 4 is still pointing to 0. So if I just change this one to say, let's say 1, and put that one to 15 times or 50 times, doesn't matter. Now I call it zeros, still it's just a bunch of ones. So I rather call it ones. With the NumPy, you could do these kind of things in the fly and then do manipulation as well with it. I'll cover that one later on today or next week, but I'll just give you a quick overview of NumPy with comparison to list, since we're discussing that one. Let's say I want to just have a list of list 1 is equal 1 to say, I'm going to do a comprehension so it's faster this way. I'm going to say, actually, let's do the simple way first. So this is 3 elements. List 2 is equal, and then say 2, 2, 3, and 4. So that one. And now I could say list 1 plus list 2 is going to just concatenate. I could also say list 3 is equal list 1 dot extend, and then list 2. That would do the same thing. List 3 now has both of them. List 1 dot extend list 2, and then list 3 did not have anything. Why? So list 1 dot extend list 2. Oh, extend. List 1 dot extend, and then list 2. Okay, so you can just type it in. I use that E there extra. So list 1 is now on both of them. If I want to just assign it at the same time to list 3 is equal, and then list 3 is there. It did not get it because this is inline. So inline, which means that it's going to do this one. So now if I want to do this, and then list 1, it just keep growing. So as you do it, it is growing, and then inline. So if I want to just do sort this one, first of all, the number 2 is duplicated so much, right? So even if I sort it and say list 1 dot sort is going to just list 1 is sorted, but notice that 2s are put together, 3s are put together, and 4s are put together. You can do that. So list 1 is there. Let me just go back to my original example so I could give you the NumPy example first. List 1 is equal, I'm going to create 1, comma 2, comma 3 first. And list 2 is equal 2, comma 3, comma 4, comma 5, that's fine. As long as it's 3 elements for each one of them. length of list 1 is giving you, length of list 2 is giving you, and then if I just say list 1 plus list 2 is going to work, but list 1 minus list 2 does not mean anything. It's not going to work. Or divided by does not mean anything, or multiplied by does not mean anything, because with those manipulation you cannot do it. You can do multiplied by 2 to extend that list twice, or multiplied by 10 to show the same number 10 times. You could do that one, but you cannot multiply 2 lists. In order to do that one, so watch, list 1 is there and list 2 is there. If I say import numpy as np, import numpy as np, so now np is there, dir of np is there. So I could create one element, say a, or list 1, doesn't matter what you call it. You could say list 1 is equal np.array, and then the function array takes a list, and that list would be my my list 1. My list 1, was it my list 1, the name? Let me double check the name. List 1. So I'm going to just say list 1. Let's first try that. Now list 1 is there. Yeah, so we created a list within a list. And now if I just look at the data shape of that one and say np.shape, shape of that one, without the method, shape is that, and then np dot, not np, sorry, list 1 dot shape. Sorry, I typed the wrong. Dot shape without the parameter. So that's 1,3, meaning that list 1 has 1 row and 3 columns. So if I just do a simpler one with, let me just do list 1 is equal, I'm not going to put it into the list first. I will list within list. I'm not going to do that one. I'm going to try to show you the example of multiplication first. So np.array, I'm going to say 1 comma, I'm going to say a function and then list 1 comma 2 comma 3. Let's say you do that one. This will create a list 1 as the 3 elements, and then list 1 and dot shape will just give you one dimensional with 3 columns, 3 and sequence 3 length of list 1, 3 elements, and then list 1 dot number of dimension is also going to give you 1 dimensional structure. So I'm going to create another list 2 with this example. And then numpy.array is the function. This time I'm going to say the list is 2, 3, and 4, or 5. So list 2 is also there. List 2 dot shape is also 3 comma, list 2. I just have to do 2. And then list 2 dot number of dimension is the same. They have to be the same dimension. So now you can say list 1 minus list 2. You could do subtraction, and list 1 plus list 2, the 2 numbers are added. Notice list 1 is this, list 2 is there. When you add 1 and 2 is going to be 3, and 2 and 3 is 5, and 8 and 3 is going to be 3 and 8, 5 is 8. So now if I just do multiplication, it will also multiply it. Okay, so the list, now you could do this one with list comprehension, and you could do the same thing with Python with list comprehension, and you don't have to do small numbers. you could grow in size. So let's just do list compression first. So if I go list 1 here, I'm going to do x for x and numbers. So let's say for x in a range of 100 elements. Let's not do 100, let's do 20 of them. That's fine and long enough. Range and then this. Now list 1 has all those elements. And then the next thing I'm going to create list 2 for x in a range. But this time I'm going to say 20, comma 0, comma -1. So I'm going to go backward for the list 2. List 2 is this, 20 down to 1. So length of list 1 is 20, length of S2 is also 20. That means the two lists could be added or multiplied if we're using NumPy. But with list, you could still not do list times list. You cannot list 1 times list 2. You cannot do that one because that's not allowed within list. But if I just want to do a plus for extended, you could grow that one. So list 1 has that, list 2 has that, and then list 1 extend is equal list 2. You could grow it like that. Now list 1 has bigger list. And then let's say I want to copy this one to list 3 is equal list 1 dot copy. This one I could copy it. Now list 3 has the element that I want to copy it. ID of list 1 and then ID of list 3 are different IDs. That means that the copy is, if I by modifying one of them and the other one is not being modified because I'm using copy. So if I just say list 4 is equal list 3, now this is a duplicate copy of it. So let's modify list 3 sub -1, the last one, which is 1, to give it a list of, say, Wahid. So now list 3 has that element, and list 4 is that element, and then list 1 is not. List 1 is still the same because we use the copy command. When we use the copy command, and list 4 is exactly a pointer to the same memory location, and then it is doing that one. ID of list 3, ID of list 4 are the same. And then because they're pointers to the same memory location, by modifying one of them, like if I just modify list sub 4 sub 0 to, sorry, list that's 0, and I want to just change it to a value, say, this is a test. And then now print list 4 is there, and then list 3 is there. Both of them were modified. But if I do list 5 is equal list 4 dot copy, because I'm making a copy of it. The copy, by modifying list 5, now I'm going to modify list 5 is equal new. Sorry. Let me just do that again. Okay, now list 5 sub 0 is equal new. New like that. And then now list 5 and list 4 are different. Because list 5, when you do a copy, you're just making a copy of it, like one file gets copied to the other one. This is one list gets copied to the other list. But the IDs of list 3 are the same, and IDs of list 4 are the same because they both are pointing to the same memory location. But list 5 is a different one because we did a copy. That's why when you change an element in list 5, if I say list 5 and sub, let's say element 5 equal to Apple, then now list 5 is pointing to list 5 is pointing to that information because that element is Apple, but list 4, even though it was at one point was copied, it's not modified because it was copied to Apple. That's the difference between them. So now if I just go back to the same thing, if I just say list 1 and then list 2, list 2, and then I say list 1 plus list 2, I could do that one. List 1 plus list 2 I could add, but list 1 times list 2 does not work. So in order to make that one, I have to do a NumPy. So let's say create a and say for list 1, I'm going to call it A, and then I say NumPy.array, and this time we're going to just say you use the list comprehension. We use say we could use any number, any variable. So this part is the expression that you want to do. So num times num, whatever you want to do the expression, or just by itself num for num and 1 and a range of let's say 20 numbers. 20 numbers, and then do that one, and then let's just get all the even numbers. So you can also use the if statement here. If num mod 2 is equal, and this is not equal symbol, it's a double equal sign to match Boolean operator. So you're comparing that one by doing this num times num. This is the expression, this is the for statement, which goes to the same variable that you're doing it within that range. So if that number in mod 2 is equal to 0, then it's going to just return that the even numbers. So instead of call it A, let's call it even for E, for even. Or we could just say even. So I forgot to close this one. I have to close it. Now even has the list of all those elements, but because I did num to the power of times num, it's like the number multiplied by itself. It's like the number to the power of 2. So 2 to the power of 2 is 4, 4 to the power of 4 is 16, because I'm looking only for even numbers. So now if I just do the same thing, but this time I'm going to look for odd numbers, odd, and then I say numpy this, I'm going to do that closing, and then I have to just say when remainder is equal 1. That would be odd. So now odd is that 1, and then 3 times 3 is 9, and 5 to the power of 2, or 5 times 5 is 25, and so on. 7 times 7 is 49, and so on. So we get the two numbers. Now we need to do a length of even and a length of odd. So they have to have the same kind of matching one-to-one matrix to multiply them. So now if I say odd times even, I could do the 2 multiplication. 0 times any number is 0, and 4 times 9 is 36, and so on. So you can see that it just does it correctly. And then if I just do a division by that, you will get some numbers that are, one of them is showing infinity, because 0 divided by a number is infinity. And then if I do minus division, subtraction, or I could do addition, you will just do a calculation on those ones. So with list comprehension, it's really good tools. You could do a lot of manipulation. I could create a list called my list, my L is equal, and then I could say here and say x to the power of 2, and then say for x and range, let's say the range is 100, and then I could say f x is greater than let's say 10. Even though I started with 100, I could just look for the numbers that are greater than 10. So I don't have to start with a particular number. I could do that one, and then now my list has that numbers. I could also do this one, and instead of doing if statement here, I could say 0 to 100, step 10. And this is a start, and this is end, and this is a step, how far you want to jump in. So my list is that numbers. So each 10 numbers, as you can see by increment of 10, I could do this. Or I could do the same thing with, if I didn't have the start and end, I could say with these numbers, and then right here, say f x mode 10 is equal 0. That would just do the same thing, because basically the numbers divided by 10, remainder is 0, will give you the same numbers with step over. So the mathematic formulas is up to you how you want to do those ones. It's always, when we are teaching you the basic building block of Python, we're introducing you to the terminology as well as the methods that are available, system-defined functions. But each one of these things that you do here, you could write it inside of a Python block of code, which is a function, and you could define a function to do that one. So in order to, like, for example, let's say you want to return any number that they give you multiplied by 5. You could say def, let's say increment by, or multiply by 5, mul 5, multiply 5. So you could do that one and then say num. So this is there, and then say return. This is as simple as one line, and say num times 5. And then if you do this one, the function multiply 5, and then I say 10, is going to say 50. If you say 100, it's going to be 500, and so on. Every one of them, depending on what the function returns, these kind of codes that you could do is the same thing. So if I just have multiply, let's just do this, and then we just say my list. And notice that every number, in this case, I just multiplied by 5 on the list, because that is the argument of that one. So my list is this, by multiplied by 5. Actually, in this case, it's not allowing you to just multiply it, because we're on the list. We're not in NumPy. It is just actually concatenated or extended the list 5 times. So in order to actually multiply that numbers, you have to do NumPy. So let's look at this. We say def, and we say we will call it the NumPy mul, just so we know that this is different. And then we call it num. And then this case, we're going to say return. And then what we want to do is say, let's say the list is there. What is the list actually? The list has to be, when we do the NumPy, we're multiplying that by 5. So NumPy dot num numpy.num times 5. Let's try this one first. So numpy multiply 5 and num. In this case is my list. So it did not work because num is not recognized. Inside here, numpy, I have to declare it first. So let's do that before we write the function. Let's write it here to see how we do it with numpy. So numpy, normally you create a list of this called a, and then np.array, and then you say a list of x to the power of what we wanted to print 10. Okay, so let's x for x and range 100, and then say if x mode 0 is equal 10, mode 10 is equal 0, mode 10 is equal 0, and then you just do that one. So oops, I have to close it. A is there. So now A has the element of the list, and then we say A times 5. We'll just multiply it, yeah. So now the A is the element. We could do a function, say def numpy, and we call it multiply of 5, and then we say num, and then whatever is the definition, say return, and then what we are returning, we're returning the numpy times a. In this case, a is not defined locally, so we have to define a inside our function. And then the way we write a is, say a is equal np.array, and we write that and say x for x and range of 100, if x remainder 10 is equal 0, close it, and then that is the function return, but to the power of 2, to the power of 5 in this case. So we return that, and so return is equal, a is equal, so let me do another one. Say def numpy m5 num colon, and then we say a is equal. We have to do all this thing here up to right here. And then, so locally, that is the array that we want to do, and then return a times num. That would do it. So you have to first get a value of a, and then that one. So now if I just say numpy multiply 5, and then I say 5 here, because it's passed, that's what there. If I pass 15, even though the name of the function does not make sense in that 15, because I say numpy multiply 5, but we could just give a generic name. We could say multiply by, and then so we could say def multiply by, and then just put this number, and then the array that you're creating within the numpy, that could be anything. So if I want to just say, just create an array of 5 of them, and then say return a times a num. And this, since it's multiply, you have to multiply it. If it is addition, you do addition. So now we say multiply by, and then the number is 5. It will do, I typed it wrong, sorry. Multiply by 5. Oh, I did wrong. I messed up. When I declare it, I did not name it with y. So that's why. And so if you could say 2 and then just does it, if you do it 1, the number and there, A is still pointing to that one. So as soon as you buy 1, it's going to do. But anything with 0 is going to be all zeros. So you could write your own function to do something. If you want a larger number, there. If you want to just do A times A, that is, let's see, what is A, line A in module, line 3 by multiply by, operand could not be broadcast together with shapes. So that is not allowing it. A is there, and then multiply by a different number. In this case, number is 11, it will do it. But if I just do it by A, it will not allow it, because A is actually creating it as a local value. But if I just assign A to B, B is equal A. Now A is pointing to the same element and B is assigned the same element. I could say A times B, it will work. And then I could say multiply by B, it's not allowing it. So let's see, operand could not be broadcast together with shape 20, 10. So one of them is the shapes are different in that case inside the tuples versus the other one, A dot shape, and then B dot shape. But there are 10. The length of them, both of them are the same, and length of B is the same. Number of the B dot number of dimension is the same. Sorry, not bracket. B dot number of dimension is 1 dimension, and then B dot size, A dot size. Yeah, the same number of bytes. Okay, so any questions so far before I continue on? It's what time is it? 9:20. Any question? Okay, so let me go here and see what other things. Yeah, so inside this one, we need to cover a lot of other methods. I'm going to cover you more methods with the list first. We jumped into NumPy to cover some stuff. And then with the other ones with port that we were using, let's see, right here, there's a lot of the packages like pep and other ones we could do, pandas, we could look at it and everything else. I'm going to close this one also to speed up the computer, so we could have this. Here we could cover these list of objects with whether you are covering it here or there, doesn't matter. So let's just go first on the list comprehension. I have some more example here. And then when you create a list, for example, my list 1, I declared here X is equal, this is inside PyCharm, so we can run the code and test it and see it as well. So if you look at this list for by itself, if I comment everything else here, and the way you comment everything here, you put 3 quotes, and then you close all the way here, 3 quotes. Now, and those are comment. When you run it, only the first 3 lines will be run. and this 2 lines will be run. The other ones are common. So this one is inside your assignment. Always you want to use shebang and then Python if you're using Windows, and if you're using Linux, let's say Linux, you want to use type cls.py. See, there ls-l.py. So what is it? CLS. Yeah, more cls.py. So if you're doing it within Linux, and instead of the shebang Python, you have to say shebang user ben env. If you're doing it on Mac OS X, it's the same thing. So this one, it says run the env command. So which env, it's automatically under user ben. That's why this one is hard coded to user ben. Automatically it finds the env, but then it's going to look for an interpreter called Python, which Python is going to just find the version that's there. Python-v is going to run 3.69 in this case, is going to run this code against that one. Similar on the Windows, it's going to look for that one. These other 2 lines are examples of how you want and the header information. When I ask you, say, what does this script do, and what is who wrote it, and all that information, you should have it, and that things. Sometimes you want to write a date and the modified date. Every time you see this is version 1, if it's a big application, you want to maintain all that information on CVS or some kind of TK-CVS or CC Harvest or so wherever is now GitHub and Git is basically used by everybody to do distributed CVS kind of work. So you could check in and check out the files, and you could work with 100 developers on a company. You're not going to overwrite other people's work. Other people's are not going to overwrite your work. You're opening your source code and you modify it and set it to the thing. Excuse me. So right here, I'm going to create a list called MyList. And then here, I'm using the comprehension method. By just putting this bracket method, here I could use a for statement, and I say, and the variable in this case is x. This could be an expression also. I could say x to the power of 2 multiplied. So whatever the number is, and then I say a range of 10, and then I print it. So if I just do this, if I compile it and say run this code, and then the name of it is list comprehension, it will run, and then it's going to show you the output right here. Notice that the output is right here because we're saying whatever the number to the power of 2, so 3 to the power of 2 is 9, and the 4 is 16, and 5 is 25, and so on. So you could do this one, but if you just say, I want to skip the first 3 elements, then you say here if statement. You say if x is greater than 4. So now those ones will not be there. The Boolean operator that is going to check after with the if statement is going to run, and then if I run it again, run it. This time is 1, 2, and 4 is not going to be printed. It started with 525. And then you could also do Boolean operator to say greater or equal to 4, or greater or equal to 5, or whatever. So this one will just also do the 4 now because of that condition of Boolean matching. If it is there, do it, and then otherwise don't do it. So now 4 is also 16. So this comprehension, you could do an expression in a for statement, but notice the variable that you do here, whatever variable you say here for I, then you have to use this variable here also, and then this variable also here. You cannot say I here and then X here, because that X would not be defined. since you define that variable here, you could do the same thing. And this time I'm going to just only look for numbers that are greater than 50. If we, so only the last two elements, 64 and 81 will be printed in this case. So if I run that one, so it's empty, greater than or equal than 50, because this number is actually not greater than that one. So in order for me to just do the calculation greater than this, I have to do this one maybe greater than 8 or greater than 7. Let's say 7 would make sense because I want to do 8 and 9 maybe, and those are two numbers. But if my range was 100, yes, 50 would have made sense. So 7 greater or equal, if I just want to eliminate 7, then obviously I will say greater than. So the list comprehension, we cover the number of them. I'm going to just leave these ones commented. I'll just go over them quickly. This one is x to the power of 2 in the range 10. Actually, let me just uncomment one time, and I will just run all of them, and you will see the output for all of them. So in order to see the output of all that one, so each one of them, this is the first one, second one, and the last two, as you can see, 20 to 0. This one start with 20 and down to 0 minus 2. So it's like decrementing it within the for statement as I go. And then automatically it says 20, 18 up to 2, and then it stops. When it's 0, it's not going to print that one. But then this one is going to show you the odd numbers, because range of 20, if number mod 2 is equal 1, then it's going to give you the odd numbers. What we did also with the other examples of that NumPy with even and odd. So let's save this one, and then we're going to just, that's fine, automatically it's saved within NumPy, you don't have to save it. I'm going to just go a new file, and then say new Python file, right here, new Python file, and we call it, say, list examples. So let's say some of the functions that you want to do, and instead of examples long, and then we could call this examples, that's fine, .py. Since we did that one, we haven't started anything, we just say Python, we say purpose, what is the purpose of this one? We say to show some of the examples of Python list methods. And so here you could say written by Wahid on whatever date it is. Today is 10/1/2020. So here, this one is that, and then we start off here, say, first say type of a list. We just want to see that one. Then I say, okay, this is a list. I'm going to create a new list called my list is equal an empty list. So you could do that one, say my list 1 is equal a new list 1 called list, and then this, you could do that. So let's print each one of them. We could say on the bottom of this one, say print, and then say my list, and then here we say print my list 1, list one, and then here we say type of list, and then print directory of list to see what are the list, right? So this is print the type, and just to show you the type, and then here print the directory of list of them inside a PyCharm. So that is good. This is a simple one. So we're going to save this. We're going to run, and then we manipulate it more with more objects here. So this is okay, save it. It's already saved. Sorry, I'm inside PyCharm. So I'm going to say run, and then the name of the script in this case is list example. Okay, so the first one it says class type, which is type is list. The next one, a dir list, that shows you all the list of the dirs for the list itself. You can see it has a lot of methods, sort and reverse, pop, extend, copy, and so on. And also the dunder method, like list.add. This is one of the methods with double underscore, or list.contains. So let's just say we're gonna do, these are empty list. On both of them, you just see it's an empty list. So now we are adding a element to it. We could add to the list by doing like my list dot underscore underscore add underscore underscore, and then you have to do another list on the method. So the method would be like 1, 2, 3. Let's say those one will be added, and then my list dot underscore underscore contains, and then underscore underscore. If you see for the word one, it is going to return true. So let's just run those two. If we run this, what happened here? Okay, so where's the output? Let me see, the output is, oh, yeah, the output is here, but because we're not doing anything with these statements, we have to do a print on it in order to just know the actual value of it. So this is added to my list. And then now if I just say print my list again to see what it is going to print, and then this one is going to return a true or false, contains, and then say if my list dot one contains this one, say print yes, yes, the number one was found. Let's say else print no, the list did not contain the number one. So let's say we do that, and then we run it this time. Okay, so the first one, it print that empty list, but now notice that when we did the add, it did it inline. My list went to 1, 2, 3, but then my list is still empty. So now says no, the no part, because my list did not change. In order to change it, so we had to do this. In order to change it, we could do let me just do this. In order to change it, we have to do my list here is equal, and then just print this part, and then move it there, say my list dot add. So now my list is there, and then print my list back here, my list. But this my list dot add only requires one of this, and that is good enough. And then print my list now is going to be there. This time is going to say true because we just not did it inline, we modified it inside the actual list. Okay, so my list is still empty. No, my list actually has that one. My list dot contains let's see if this one is the number one like this, because it's not a string. I think we have to put a list like a number one on the list. Let's see. Okay, so that was it because we were looking at the string rather than a number. So that says yes, the number one was there. And then if you change that one to a 3, for example, or 5, it's not going to be there. Since it's not going to be there, it says no, it's not there. Okay, so now let's say this, and then right here, we're going to use another method to insert the number that is missing. So no, I did not find the number. So in this case, we're going to just say the number, comma, number. So number is going to be matched here. We say number is equal 5, and then here we just put the number 5 as num. We use a variable. That way we don't have to do, we could even do a placeholder like num here. And then here use a function f statement. And then here also f statement. And then the number, the list did not contain the number. And then a placeholder num. And then get rid of this. So this would do the f statement. Because we create the variable, we're passing that variable 5 inside here, and then it's going to run it. So if I just run now, and instead of saying 1 when we compare 5, it's going to say 5 when we compare 5. So that is better by declaring a variable dynamically. So now know that the number 5 did not contain. So we could even just say checking against the number here and say print checking against the $, not $, num. And then by doing that one, we use also F statement. So we could now have a little bit friendlier testing to say I'm checking against the number 5, and then that number 5 is no longer there. And you can see that no, the list did not contains the number 5. But again, because the list is empty now, we're going to just do the something here by inserting the number 5. So say my list dot insert on the first element we add the num. So this is inserting it. And then now we do another testing here. Oops. Undo typing. Yeah. So we could copy this, Control C, and then put it here. So this time, because we inserted into my list, see if my list just grow insert is going to increment this one, add to it, or it's going to do inline. So we could compare it, and if it is inline, and that my list automatically modifies, then it says, yes, the number 5 was found this time, because we did it. So This time when it is finding it, then we need to do a print. So we say print my list to show that yes, we found it. And here, if it was found, also we want to say print my list. So my list is there, and then you run it. So now it says that yes, the number 5 is there because we want to insert it on item number 1, which is a second element. It inserted there. Now, if we just insert it, look for number 3, and change this one to number 3, it's going to find it. But then again, this is going to also insert it. So we're going to have duplicate number 3 this time. Notice that if we change that number variable to 3, now we have 3 as a duplicate twice, and it found it. So if I just want to print the count of 3, and the first time we do a count on it, when it found it, say print count of the number, count my list dot count, and then num. If that number is going to be found there, you print it once here. The first time is going to say once. The second time, because we did an insert on it here, so this one is going to say on the list, is going to say twice because it's there. But if it inserted every time we do it, now it might be 3 times. But no,